So let's compare the policy instruments discussed earlier based on the list of criteria that was also discussed earlier. And we're going to start with cost effectiveness. Earlier I derived the conditions for cost effectiveness. We're trying to achieve an environmental target at the lowest possible cost, and we do so by minimizing the total cost, the cost to all polluters of emission reduction, subject to the constraint that total emission reduction is greater than or equal than our target. We do so by forming the Lagrangian and then taking the first partial derivative of that Lagrangian to the thing that we're actually trying to control here, that is emissions, and set it equal to 0. And if you then work through that, what you find is that the first order condition for cost effectiveness is that the costs of emission reduction at the margin for all polluters N should be equal to the shadow price of the constraint, and that shadow price is the same for everybody. So the condition here is that the marginal costs for emission reduction are equal for all polluters. So now what happens if instead we have an environmental tax? The cost function then becomes the cost of emission reduction as it was before, but the more emissions you reduce, so the greater M stands for emission reduction, not emissions, the more emissions you reduce, the less tax you pay, so you have to subtract that from your cost function. And that is what a private company, a private polluter would do when faced with a tax on its emissions. It's an unconstrained optimization, so it just wants to minimize the total cost or the cost to this particular company by choosing its emission reduction level M sub n, and it just wants to minimize that, so no constraint. So this is you simply set the first partial derivative of the cost function, the CDMN, equal to 0. The CDMN is beta half gamma m squared becomes gamma m minus Tm becomes minus T. So bring T to the other side of the equation, and what you have that with a system of environmental taxes, the costs at the margin of every polluter N is equal to the tax emissions tax T. And this is just the first order condition for a social planning exercise where the lambda is replaced by a T. But the condition here is that the costs are the same at the margin for everybody, and the solution here is that provided that everybody faces the same tax, that the costs are the same for everybody at the margin. So a emissions tax is automatically cost effective. It reaches the environmental goals at the lowest possible cost. Now what happens if we have a subsidy instead? Well, the cost of emission reduction are still the same. Now we have to subtract Sm. Why do we subtract Sm? Well, the more emissions, the greater M, the greater your emission reduction, and the greater your emission reduction, the higher the subsidy and the lower your costs. So this becomes a minus Sm, right? This particular equation is exactly the same as this one, with the T replaced by an S, and the first order conditions are the same with the T replaced by an S. So also a subsidy reduces pollution at the lowest possible cost. It's automatically cost effective. Now what happens if we have tradable permits? Well, if you're a permit buyer, then essentially the more you reduce your emissions in-house, the fewer permits you need to buy, so the lower your cost. And for a permit buyer, it is essentially a tax, because instead of paying the tax you buy permits, but that doesn't matter to you, right? Instead of giving the money to the exchequer, you give it to another company. So for permit buyers, indeed, you need to subtract PM, because the more you reduce in-house, the less permits you need to buy. So that is a cost saving. For permit sellers, it is also minus PM, because the more emissions you reduce in-house, the more permits you can sell, the greater the revenue of your permit sale. So also for permit sellers, the costs go down the higher your M. So also for permit sellers, the proper equation is minus PM sub N. So this equation has exactly the same shape as this equation and this equation. That means that first order conditions are that the costs at the margin equal P. So if everybody is in the same market and everybody faces the same permit price, then the marginal costs of emission reduction are equal for all polluters. So environmental taxes, environmental subsidies, tradable permits, provided that taxes are homogeneous and subsidies are homogeneous, and everybody is in the same permit market, everybody faces the same price, are automatically cost effective. They meet the environmental target at the lowest possible cost. So taxes, subsidies and tradable permits are cost effective by design, provided that everybody faces the same tax, the same subsidy, or the same permit price. Direct regulation, I argued before, is unlikely to be cost effective. It is unlikely that the regulator knows so much and is allowed to give everybody the exactly right target, so that costs at the margin are equalized. And there are exceptions to that, but then you're talking about a very knowledgeable regulator and small number of polluters who all basically do the same thing. Institutional instruments, voluntary agreements, actually are designed to use more information and therefore are more likely to be cheaper than direct regulation. But there's a mixed bag there. They may also lead to special pleading and exemptions and those sort of things. It may be that the regulator is captured by industry or particular companies in the industry and gives out favors to those companies, and that immediately then implies that costs are not equated at the margin. Cohesion bargaining would lead to Pareto optimum, therefore to a cost-effective solution. But cohesion bargaining only applies to a situation where there's a small number of polluters and pollutees. Administrative costs is a mixed bag, and direct regulation really depends on what is going on. It's often expensive to the government because it involves a lot of form filling and targets to be set and committees to meet and those sort of things. That of course makes it very attractive from the perspective of the regulator itself. Essentially they increase their control and they increase their budget, but it rarely comes cheap. Voluntary agreements may be cheap because as long as the companies, the polluters actually step up and do a lot of the monitoring and a lot of the groundwork for themselves. Such things as establishing property rights, saying, well, this is your resource and this is not theirs and this is what you can do and you can't do, is actually fairly cheap because it's essentially just a legislative process and that's it. But if you need to dispute these things in court, then they actually can become very, very expensive because lawyers are expensive. Taxes and subsidies can be very cheap. administratively if they are based on existing fiscal instruments. Earlier gave the example of plastic bag levy, which is an excise that is levied when you buy stuff, and excises are already paid in the supermarket. So all the administrative systems are in place, and it's just a variation on a theme. New taxes can actually be expensive, and subsidies, it all depends. If you can piggyback on a system of subsidies that is already in existence, then it can be cheap. But if you need to set up a whole new system for this, then it may actually be expensive. Same is true for monitoring. Of course, if you tax something, you need to know what to tax. If a tax relates to energy or to agriculture or to things like that, then it is relatively cheap because we closely monitor these things already. But if, say, you want to install a congestion tax, it would be a good idea to regulate traffic and reduce traffic jams and so on and so forth. We don't do that at the moment. We don't monitor traffic closely enough to actually charge people for their road use. And that would mean that if you go for a congestion tax, you actually need to set up an entirely new monitoring system with all the data requirements, all the privacy requirements, and everything that comes with it, and that can actually turn out to be very, very expensive. Tradable permits are also relatively cheap for the government because essentially it's the cost of monitoring these things, and there is no big administrative burden placed on the government, on the regulator, provided that the monitoring is in place and that your companies are relatively well behaved. Environmental effectiveness is our next criterion. Good thing about tradable permits is that you know the environmental impact because you set a cap on total emissions, and that is it. So provided that there's no illegal dumping and those sort of things, you know the amount of emissions that goes out. The bad thing about tradable permits is that you can't predict the price. You can't predict the price of the permit, so you don't know the costs of your policy. The good thing about taxes and subsidies is that the costs are known, because the margin cost or the margin are the tax that you set or the subsidy that you gave. So you know these things because that is what you just decided. The bad thing is that the environmental effects are unknown. You can set a tax and then people would reduce their emissions, but you don't know by how much unless you happen to know all price and substitution elasticities, which you don't. So the environmental effects of taxes and subsidies are uncertain. Direct regulation, if it's on the outputs, you know the environmental effectiveness. If you say, well, every plant or every power plant can only emit 100 million tons of sulfur every year, and there's 17 of these plants in my country, then you know how much SO2 will come out of these things. Again, assuming that everybody follows the rules. So direct regulation on outputs, there you know for certain what the environmental effect would be. Not so if you regulate the technology that is used, how things are produced, or you regulate what goes into the production or the consumption process. So if you put a standard on fuel efficiency, you say that cars need to get more miles per gallon, then yes, that would reduce fuel use and therefore all the emissions that are associated with fuel use, be it NOx or SOx or CO2 or whatever comes out, PM10, PM2.5, those things would fall, presumably, but as soon as you make cars more fuel efficient, you reduce the cost of transport, and as a result, people will travel more, and they will ship more goods. So you see a sort of a rebound effect, and that rebound effect is unpredictable, but it does mean that some of your environmental gains are taken away by the fact that you made travel and transport cheaper. So if you're directly regulating the input into consumption and production, or the technologies that are used in consumption and production, the environmental effects actually become unpredictable. If you rely on coercion bargaining or something, then essentially as a government you give things away, you lose control over the whole thing, so you can't really predict what would happen. So there you don't know the environmental effects in advance. Look at effects in the let's look at effects in the long run. A good thing about taxes and tradable permits is that you create a continuous incentive to emit less, because if you emit less, you're gonna get a greater tax reduction. And if you emit less, you can sell more permits, or you need to buy fewer. So that is a good thing. The same is true in principle for subsidies. You create a continuous pressure to keep on reducing emissions, but of course subsidies increase the profitability of your polluters and therefore attract new entrants and new capital into this particular industry. With direct regulation, again, it's a mixed bag. It depends on how exactly you do things, but if you just set a standard for emissions, or a standard for input, or a standard for the technology that is used, then once that standard is met, there is no reason to reduce emissions further. And the only way to get further emission reduction is to keep on sharpening the targets and the standards. With taxes, that goes automatic, because there is the pressure to keep on reducing is always there, but with standards you just need to keep on working on them, and you need to keep on changing the regulations and perhaps the legislation to do so. So that is a good thing about taxes and tradable permits, that also in the long run you keep on improving the environment. Flexibility is our next criterion. Why is flexibility important? Because we are uncertain about a great many things, and new information always arises. It may turn out that the situation is a lot worse than we thought. It may turn out that things aren't as bad as we thought, and that means that you have to adjust your regulation. No instrument really stands out here. If you rely on environmental taxes, then everybody will be happy. If you lower the taxes, then everybody will be cross. If you increase the taxes, same is true with standards. Everybody will be happy if you go for more lenient standards, and everybody will be cross if you sharpen them. So that does not provide a lot of flexibility. The only real exception here potentially are tradable permits, because if it turns out that you released too few permits, you can always release more. But the government can also say, well, I released too many permits, and then can just start buying them up and retiring them. That's expensive, but it is perhaps easier than raising additional taxes. good thing about tradable permits is that it's not just the government that can tighten the target in that way. Also, NGOs or private people can decide to buy those taxes, or if they have them already, to hold them taxes and not use them, and that can sharpen environmental policy. So it's no longer under complete control of the government, and that's completely opposite to, say, target setting. Only the government has that power, or taxation, only the government has that power. Tradable permits, other people can actually step in as well if they don't like government policy and have the funds to actually make a substantial impact on the market. Last but certainly not least, distributional consequences are important too. In general, environmental policy makes things more expensive. And oftentimes environmental problems are associated with necessary goods. If you're talking about energy, there's a lot of environmental problems associated with energy. Or if you're talking about agriculture, there's a lot of environmental problems associated with agriculture. Or if you're talking about transport, a lot of environmental problems are associated with transport. These are all necessary goods and services. And that means, by definition, that poorer people pay a greater share of their income towards these things. And if you intervene in that market, you're going to make things more expensive, and you're going to make things more expensive, particularly for the poor, whereas richer people are less affected by this. And there's no escaping there. The good thing about taxes, tradable permits and subsidies is that you actually do things at the lowest possible cost. So the price rises of these necessary goods are lower with cost-effective instruments than with direct regulation and those things. And that means that the distributional effects are less pronounced. Now, the good thing about taxes and the good thing about auctioned tradable permits is that the government has a revenue at its disposal. And with that revenue, it can do nice things for the people who are hardest hit. It can increase unemployment benefits or pensions or tax credits or things like that. And that is a big advantage of, at least in theory, of using taxes and auctioned tradable permits. Of course, if you use subsidies, then the government does not have money. Actually, the government lost money. So taxes are good in that sense. But these equity concerns are real and need to be thought of, and with some instruments can actually be countered. Of course, if you use direct regulation, then the government doesn't have revenue either. But with taxes and auction tradable permits, you do.